Well, hey folks, it's Justin from cartoonsmart.com, and we're going to talk about SceneKit and ARKit today. So in Xcode 9, go ahead and head over here to create a new project. iOS, augmented reality, and we'll just call this SceneKit lesson 1. And you want the language to be Swift and the content technology to be SceneKit. Be sure you don't click on SpriteKit, otherwise you'll be really confused from here on out. So click on Next. Just put it anywhere, desktop, probably the worst place for me. And let's head over here to the included art. You can see that you've got a texture in here and a ship which uses that texture. And we are going to get rid of both of them. So just go ahead and select them both. Get rid of these guys. Move to trash. And then be sure you've still got this selected over here. Just go to File, New, and it shouldn't give you a new file type option. Most of the time when you do that, you do get the option to pick out some different file, but as long as you're selected over here, it's just going to make a new scene file for you, and that's where we're going to play around. So let's call this main scene, give it a name, and by default it should have a camera in here. So if you go over here to the scene graph, all right, and that's right down there at the very bottom. Okay, see that little button I'm pressing. You can just go ahead and get rid of the camera, because for an AR game like this, we essentially are the camera. Okay, and then let's just drag out an empty node over here. You can see it just, wherever we kind of dragged it out to is where it lands. But let's go ahead and set this to 0, 0, 0. So just 0, 0, and 0. And we might not see it anymore. There it is. Let's give it a name. How about just dummy node? Okay. And we're going to use this to just basically put children inside of it, and then we'll move around the dummy node, which will contain everything. So the first thing, let's just go ahead and throw a box in there. Again, just drag it out wherever, but then as soon as we get this in the scene, let's go ahead and set the X, Y, and Z to 0, 0, 0. And then don't ever mess with the scale. That's what I've learned the past few days. That really kind of messed me up for a while, because kind of the preferred way of sizing this thing, right? So if you want this to be kind of more like a plane to bounce a ball on, which is what we'll do, head over here to this next tab, the attributes inspector, and set your width and your length up to something just a little bit bigger. And then you could, if you want to set the height down a little bit, then you've got kind of more of a plane-like shape to this box. There is actually a plane over here too, yeah, I just really wanted to point out, just leave the scale at 1, 1, 1, 1. Okay. Same thing will be true for the ball that we add in here right about now. And 0, 0, 0. Actually, for the for this, let's set the Y up quite a bit. Okay, so what we'll do is we'll have a ball that just kind of falls down here, and we'll set the restitution or the bounciness to both of these items up around 1, so the ball just essentially bounces on here. And let's see, for the name, let's call this ball, and we've got our box over here, and let's make them children by just children of the dummy node by just, that'd be a good movie title right there, children of the dummy node, by just dragging them underneath, just kind of within that, and then you can see it just kind of folds it up and down. And then I should point out that you do have the option of putting in a physics body over here. I kind of went down this road for the past day and a half or so. It's not a good idea. Don't do it. Okay. So normally I would say do that if we were using SpriteKit. But what I found is we're in a little bit better shape if we set these at runtime. And to explain that, I think it would take too long. So let's go ahead and just real quick set some different colors over here. So we'll make this blue for the for our box, and then for our ball, let's set that to be red. Good colors, I think everybody can kind of agree on, right? I guess unless you're in a gang or something. Yeah, let's head over here. Let me save up the file. I think I saved it, yeah. And then yeah. And then let's go, let's head to the view controller here. And instead of our ship, we're going to set this to be main scene. And then what we'll do is work with our, what do we call that again? Dummy node? Yeah, dummy node. Okay, so that's our container with everything in it. So just come down here to the bottom of the view did load and write we'll call this dummy node equals scene.root node, And the root node has all of our children node in it, including our dummy node. And then we're just going to identify it with the name that we gave it. So with name, and then put in there dummy node. And recursively is the other option you get to put in here, recursively. Not sure why I didn't fill it in, but there we go. If you want to find out a little bit more about that, oh, and you know what? Here's the problem. I got an extra S in there. There we go. Child node. There we go. You can see, the recursive thing has to do with just traversing the child node subtree, blah, 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 blah. Read on your own, right? A little bit too technical for right now. And then what we're going to do is write dummy node dot position is going to equal, and then here's where we're going to change the position of this. So we're just going to put in here our scene vector, and this will move all of the children with it. Okay, so I'm going to set the Y down a bit, and also the Z backwards away from us some. So that way, basically when we run this, everything's not kind of right on top of us. And then in case you're curious about the question mark, if this is, I guess, kind of considered optional because there might not be a child node with the name dummy node. So, it's essentially this shouldn't crash on us with the question mark in there, setting the position of that, right? It should fail gracefully. Okay, so let's build it. I'm gonna hit this over here in a moment, and then I'll show you guys what happened. And here's what you're gonna see. So your little box there. If you look up, you're gonna see the ball. Obviously, it kind of stays in some sort of relative position there. Remember, it's actually further away than you would think. Okay, and further back and further down. All right. So if you want to change these numbers a little bit, go for it. Just to experiment what's going on. But just keep in mind that if the closer these are to 0, the more likely you're gonna have to stand up off of your desk and kind of move back a little bit to kind of properly see that box. At least the ball is pretty high up. Okay, so. All right, we've taken care of kind of moving everything, offset from our initial position, which is important. And also of equal importance is that we didn't have to do it to every one of our things in there because we had this kind of dummy node containing them. And that's one of those things that kind of early on I was like, I think I'm going to need to figure this out, how we're going to do this. Okay, so another thing that I want to hit on here is just kind of iterating through everything that is currently in our scene. I always think this is important. So what I'm going to do is write, basically just reference everything in that same root node again, which again it also includes our dummy node. Okay, so root node, just consider, hey, that's everything. Enumerate child nodes. That's what we're going to throw in here. And let me just hit return a couple times and see what happens. It didn't exactly do what I wanted. Let's do this. So after your opening squiggly bracket, put in here node in, and then just underscore in, and then you're going to close this off a couple times. Or no, are you? I don't think you are, actually. I think we got it written. Okay, so what this will do is basically we can just refer to whatever node the code is currently looking at as just writing nodes. So we could say something like if node.name equals ball. We know we've found at least one of possibly many nodes named ball. Okay, it's going to iterate through all of them. And we can also look for our box in here too. All right. And if you wanted to, you could just put it here, print, found ball. Okay, and do the same thing down here for found box. And I'd say go ahead and just run that on your own. Okay, and what I'm going to do, and what you should do too at some point here when you're done testing that, is go ahead and declare a scene node for our ball and our box, so that way we can kind of hold on to a reference of both those items after we locate them in the scene. Okay, so, and this is really simple. If we find one, we're just going to say ball is going to equal node. All right, and the same thing will happen down here. Box is going to equal node. And I went ahead and ran that just with the video on pause, but you can see down here at the bottom it says found box, found ball in the output window. Yeah, I think that's getting cut off a little bit. So to have a little fun, let's set a physics body for the ball. So we're going to say ball dot physics body is going to equal scene physics. Don't do shape, do body. And then once you start typing this, put in your opening parentheses, and then just thumb down to type, and hit return on that. We're going to put in here dot dynamic, which means it will be part of the physics simulation. It won't just be a static shape, just kind of blocking things from happening or staying still. And then we have to define the shape of this, and you can see it's asking now for a physics shape in here. So what we're going to do is write node, and then we're just going to pass in here the ball itself for the shape, and then you can just write in here options nil. We don't need to use any of those options at this point, and then put in here ball.physicsBody.is affected by gravity. If you're used to SpriteKit like I am, that'll look familiar, as will physicsBody.restitution. We'll go ahead and set that to 1. We'll set the box to have a restitution as well. And then let's go ahead and I'll show you guys kind of a slightly different way of setting up your physics shape. I mean, you could kind of break these apart a little bit. So, for example, this is really this could almost just be one line of code on its own. So let's just play around. We're going to put here let box geometry, just so you kind of know that you can set different geometry for your physics shape. But essentially what we're doing here is we're taking the geometry of the box that we've already got, and then we're creating a different or another instance of geometry over here, and then we're just going to say let box shape scene physics shape. All right. This is what I was saying. You could break it apart into different lines. Physics shape is going to, and you can see as soon as you start typing this, it's asking for geometry, so you could put in here your box geometry. So again, it's kind of the same way of just doing what we did before, but going unnecessarily further with it. So box geometry, just be sure you put in here you're essentially forcing a value out of it. And then from there, we just do box dot physics body is going to equal scene physics body, and then again it's asking for the type. Now in this case, let's set this to be static, so that means it's not included in the physics simulation, but because it has a body, it can make that ball bounce off of it. But in other words, the ball is not going to make the box collide around the scene. Essentially, you could do that. You could set the is affected by gravity to false, okay, for your box, and the first time the ball hit it, it would slightly move it around just from the force of the ball itself falling. So that could be something to try, but because it's set to static over here, you'd actually have to set that dynamic first before putting in the affected by gravity. Anyway, okay, so we have a bouncy box and a bouncy ball, and let's see what happens. Actually, you know what? Let's run this again with some light. So I'm going to come outside of this enumerator, and I'm just going to paste this in for us real quick. So we've got a scene light. The type is set to Omni. And then we are basically just attaching this light to a new scene node, right? So, because it's attached to the node, you can move the node around, position it, stuff like that. And your scene nodes have a property called dot light. Okay, so you associate that with the light, and then of course we do need to actually add it to the scene. But once we do that, we'll have a much nicer rendered scene to look at when we build this time around. All right, and let's take a look at it. Whoa, look at that. How amazing is it? Right? A ball bouncing on something else. But we have learned a bit. And you know what? Let's keep it going just a little bit here. You'll notice that in the view will appear statement, they've set up this session configuration. We could add a couple of lines to this to make it a little bit more fantastical. What we can do is we can put in some debug options so we can kind of see what's going on in the world around us, the AR world around us. Well, one, we can check where the world origin is. We can also see the basically the AR feature points or kind of little, basically what what the camera is detecting as anchor points. Okay, you'll see them in a second. And then you can also check out the physics shapes of the objects themselves, which is really important if you kind of notice things aren't going the way that you thought, right? Just like Luke Skywalker says, things are not going to go right. So, which actually has been a theme for this. For learning SceneKit over here with me. And what else could we talk about early on? You know what? There's one other little fun thing we could add in. Hold on. Okay. Crowbar in this line right here. Scene view allows camera control. Now, I told you before, we are kind of the camera in this whole situation, but if you wanted, you can basically use this to kind of swivel around the objects in your scene by touching it, if I remember right. Let me just try that. Yeah, sure enough. Okay, so let's see what's going on with this now. All right. One thing to keep in mind is allowing the camera control does sort of basically kind of break the what do I call this? The augmented reality-ness of this. Okay, so you'll see that. By the way, you like the tape on the side of that desk so kids don't come in here and ram their eyes against the corners. Yeah, so right as soon as I started messing around with the camera control over here, you can see that the ball in the box is kind of stupidly stay in place now. Obviously, you don't really want that. But one thing you are seeing here in the background is all of those little AR points or hit points that I was telling, or anchor points I was telling you about earlier. And then somewhere in here, I think I destroyed it, or lost track of it, was the you can kind of make it out right there. Is the world starting position. What do they call that again? In our world origin. So if you're just kind of curious, hey, where's 0, 0, 0 and all of this? But that's this is kind of a decent amount to, I think, take in for a lesson 1 over here. I'm going to come right back and teach a little bit more on kind of tapping the screen and basically kind of inspecting what you just tapped and finding, well, the ball, the box, and we'll also apply a physics impulse or force to it, and we'll go from there. All right, see you in the next video. And by the way, download the cartoonsmart.com app if you're not currently listening to me through that.